Hello, my name's Daniel Lurcock, and I'm very pleased to have a few minutes to get to share with you the topic of my thesis. When we talk about buildings shaking, the context is usually earthquakes, of course. But have you ever been in a building and maybe a heavy lorry has driven past, perhaps over a pothole? Or near a railway line and a freight train has gone by? Have you ever been in London and been able to actually hear the underground from your hotel room or even the theatre? See, what you're hearing and what you're feeling is ground-borne noise and vibration. And it's a real problem, partly because it's so hard to predict. And that's because of all the mechanisms that are involved. So let's take, for example, underground railways. So the vibration starts here at the train, where it depends on the weight and the speed of the train, on the suspension system, the type and the condition of the wheels, rails, and the track. And then as the vibration propagates through the ground, it depends on the rocks and soil layers and other ground factors. The vibration meets the building, and there's a dependency there on the foundation types, and then the structure and the materials that the building's made out of. And then in the room, it will all depend on the size of the room, the way that the floor's been made up, and even furniture in the room. So that's a lot of factors to take into consideration, and current prediction methodologies just can't take all this into account. And yet, we have new buildings being built above existing underground lines, and the buildings are put on springs for isolation. We have new underground lines being built with whole sections of track isolated because of this ground-borne noise and vibration problem. Now, all this isolation is expensive, it's complicated to build, and in some cases maybe it's not even necessary because it's all designed according to these inaccurate prediction methods. So this is where my research fits in. So I've been preparing computer models of buildings to investigate the parameters of those buildings that affect the noise and vibration. So I've been able to look at the size of the building and the structural components like the columns, and it's been really interesting to find out which parameters make a difference and which don't. In the future, I also hope to include the foundation types in my studies. But for now, I hope you've enjoyed this introduction to the topic. Thank you for your attention.